not. Gonna make a start now. This is gonna drive me insane. So today we're back onto networks, yes? Hurry up.
I'm really aggressive today.
Why is this oh. Okay, just let me fix this.
So, Mike. Let's go back ankle man.
Okay, boys, be sensible, please.
He's not happy today.
That's all good. Work mode activated.
I'm really not with this.
What me?
Maybe if I do it like this, it'll work.
I just wanted to be
No.
Starting.
It only just started today.
Okay, this is frustrating me. There we go. Okay. Guys, to start with, we're going to do a bit of a challenge. Casey's away. Carly's away. Okay. So, guys, today... Thanks. We're going to be looking at... basically, you have a graph and you move from one vertex to another vertex, how that works, and what everything's called. There's a lot of terminology we're going to do today. But before we start... We're going to have a go at the human knot. You would have done this a million times before.
Oh, do we have touch people?
You gross girl
Corona doesn't spread through young people. That's why you're allowed to be back at school.
Definitely does.
No, it's more like a girl cooties.
Ew, girl cooties, bro.
Yeah.
Oh, for real?
Yeah,
Nah,
girl.
alright, fine.
You would know you've never had a girlfriend.
Oh, that's good.
Okay.
Are we doing this or not?
Yeah, let's do it.
A human knot.
Not my
So-
favorite, but-
Let's do it up the back.
Oh, yeah. Which guy? Where?
Up behind the boys over there.
This is a joke.
It's alright, sir.
Let's
You
try
have
it.
a bottle of water?
Oh my goodness. Out we get, guys. Or could we... Do you want to do it in two groups and do a challenge? Alright.
Who's this one?
I'll tell you what.
I think you take my hand.
Nathan, grab Maddie's and...
There you go.
Are we all
Two hands,
Yeah.
Yes.
Then
Alright, let's get out.
I'll wait for space.
there's no space.
Oh, why don't you guys see if you can undo it? How long? Wait, before we start, let's make bets, guys. How long to take them to undo this?
I think this is not gonna happen.
Yeah.
I reckon.
Yeah, we'll walk.
I reckon within 2 minutes. Oh, your time starts now.
I reckon Haley.
Brother, I ain't getting
hungry. No, oh, my bad. No, Nathan. Hey!
Yeah, Madison bed then.
Yeah, Madison, you go underneath.
There you go.
No.
Go, you
Oh,
see
what's going on?
that?
Put
Yeah.
your foot on the ground, man. No, wait.
Why did Nathan need to go over Jacob?
Like over my
You're just killing Maddie's arms.
Maddie, just turn inside out. Yeah, there you go.
Alright, there you go. We got one.
Almost.
Me and Jacob need to Sarah.
Need to Sarah. And then Jacob, you go underneath.
Yeah, but
Yeah, woo up, brother Dan.
And follow around.
Oh, sorry. Sorry, watching car. Oh man. Anyway.
Just use three that you can get.
Oh.
Yeah, but it's
Brody, you turn into face that way. Alright.
You and Haley need
That's
to
very
helpful.
Alright.
I think
Haley,
I'm.
That would have been
Oh,
We done it.
Minute 46. That was pretty impressive, actually.
I don't know if we did we let go?
Where's the sanitizer?
I don't know, where is it? Did I hide it? I hid it.
It.
Go sanitize yourselves.
Thank you. That's it. Yeah, look at it.
Sorry.
David!
Oh my.
My hand is sweaty.
My hand is.
Feel my palm. See, it ain't sweaty.
Knees weak.
Arms are heavy. Mom's spaghetti.
Whoa, why so much?
Am I gonna drink this?
Oh, Nathan, why did you do that?
My book!
I feel sorry for anyone that listens to this recording.
No, Shane, at least it wasn't an egg on your good pants.
Okay. Alright, so what you guys just did, do you see the link to what we've been doing in class?
Nah.
Not really?
It shows right there.
It's all connected in one way, and you can make it not cross over.
Yeah, so that was an example, that was an example of two isomorphic graphs, or two equivalent graphs. When you're like all clustered and crossed over, you were able to rearrange yourselves into a planar graph. There you go. So speaking of planar graphs, is anyone remember what is our formula for Euler? What does Euler's formula tell us?
Oh, wasn't it V plus some take away?
Was this on Monday?
V plus F?
Yeah?
V plus F take away E equals 2.
That's it. So guys, using that information, can you find me for question A what E is, and for question B what V is?
Was this Monday?
I don't know. Were you here Monday? Are you ready Monday? Yeah, it was Monday.
Who was away yesterday? Ashley, you were? Do I still have it in here? Oh no, it's up here. Guys, I decided, because we didn't get to the homework yesterday, and then we worked on this one, what I would like you to do for Monday, can you finish off the homework from the other day, as well as finish off this sheet that we did yesterday?
For Monday.
For Monday.
But I won't be here Monday.
Won't be here.
Or Thursday.
Well, that's sad. Okay, I'm going to give you 2 more minutes to find those 2 missing values, guys, just while I mark the roll. Okay, Brody's here, Casey's away, Casey's here, Vincent is here, Carly's away, Nathan, Shanti, Willie, Maddie, Ashley, Sarah, Braden, Jacob, Haley, Blake, Jay, and Georgie are all here.
Teach me.
Let me check. Hang on.
We're being observed or not?
Good thing.
Oh yeah, we are. Excellent.
There's more action outside here than inside, so that's alright. Oh, this is a wild bunch. Oh, okay, there's going to be some suspension flying out of this room. Not even what you say, Blake.
I guess. You've talked me into it.
Oh, that was Sarah, probably. She's going to get a 10-day.
What?
Brady hasn't had the news yet. Someone tell her.
The jerseys were
And they're really nice.
Get them on Monday.
Oh!
Why
Oh,
didn't
you were there with the
Why didn't you
Canada
tell her that they
really,
fell
really
off
nice.
the
The jerseys, the senior jerseys. really nice.
Finally!
Oh, yeah, wait.
Alright, guys, 30 more seconds to get those two solved.
Then. Oh no, so the formula is literally up there. Everything's.
So if you have v equals 6 and f equals 4, sum them in. Minus 2. Oh, sorry, minus e equals 2. So what number? So 6 plus 4 is 10. 10 minus e is 12. So what's e? 8. That's it.
Oh, okay.
That means it has to be 7.
Oh, so that's. Okay, guys, so first one, vertices is 6, faces is 4. We sub those into our rule, we get 10 minus e equals 2. What does e have to be?
8 gone.
8. E equals 8. Okay, and then second one, b is a question mark, edges is 8, faces is 3. b plus f minus e equals 2. v minus plus 3 equals, sorry, minus 8 equals 2.
No, I'm kidding.
Thanks, guys. So we just solve from here. There's all sorts of ways you could solve from here. The way I do it is solve everything you can on the left and then move the number over is probably the easiest way. So 3 minus 8 is what?
Yeah, it's 5.
I don't know what I'm doing there. Negative 5. Because it's 3 minus 8. Sorry,
So I got 7.
You said 5.
Yes, 7.
yep. Equals 2.
Chill out.
And then if you plus 5 to both sides,
I did do 7.
b equals 7. Okay. So guys, today we're going to be talking about routes around graphs. So the different types of ways of getting around a network have some special names. The names themselves aren't super important, but you do need to know what the difference is, because like in your exam, it'll ask you something like, is this a trail or is this a walk? And you need to know the difference. I am so real. So
Surreal.
any route from one vertex to another, moving along edges is called a walk. So if you start at vertex A, end up at vertex whatever, no matter what, that is called a walk. It's like you're walking along.
This is like real math. This is like not stuff you just
Real. This is real maths. I'm not making this up. This is real. Elephant in the room. This stuff is pretty lame. So we're talking about just like walks and paths here. But in the coming lessons, I would say to something like you, is this a Hamiltonian cycle? And you need to be able to understand A, what Hamiltonian means, and B, what a cycle is, to be able to say whether or not that is. Okay? So if it finishes where it started, it's called a closed walk. If it finishes where it didn't start, it's an open walk. So I've just done 2 examples there. Can you see the first one? We go from A to B to C to D. So I started at a vertex, ended up at another vertex. It's a walk. But because I haven't finished where I started, it's called an open walk. This one, I go around and then back to where I started, so that's a closed walk. I'm gonna not get you to write down too much now because I've presented all the information like a flow chart later on, so it's a little bit easier to see what's what and why each one is what it is. So I'll just get you to hold off for the minute.
Can we write down, copy that little drawing?
We're gonna do a couple more later. So just to make it super complex, in a walk, if you don't reuse the same edge, it is then called a trail. And then in that trail, if you don't repeat any vertices, it's called a path. So a trail can be open or closed, and a closed path is called a cycle. I'm actually going to skip past this example and go over here. Oops. So this is really what we're learning today. If you have everything is a walk. So if you go from one vertex to another, it's a walk. Are edges repeated? If there's no edges repeated, it's a trail. If there's no vertices repeated, it's a path. So that's basically the summary of what we're talking about today. Yes, please. Just a more, I think that's an easier to understand way to do it. Doing it the other way can be very time consuming, writing down every single little thing. So can we get that flowchart down, please, guys? And you know how I talked about open and closed walks? Trails can also be open and closed, but a closed path is called a cycle. So if you have a path, but then the first and last vertex are the same, you call that a cycle.
Yeah.
Make sure you get that note down as well, guys. Aircon's on.
Progress the story. Oh, so it's like Left 4 Dead. Yeah, that's down, Jay. That's pretty cool. Yeah. What is it about?
Well, from this angle, we'll get the lights so people can see it.
It's gonna be a
step forward or something will pop stop.
a reference.
Must be because it's red.
It's gonna be real cringy. It's gonna be great.
And you have to give that to your teacher?
Yeah.
Has the plan?
Yep. So there's different. You can pick which route you want to go. So if he's interested in that, then he can have that. You know.
And
But
your
there's
teacher's
also another
Mr.
one.
Davies?
There's also another one where he dies because a girl kills him.
Almost done.
Okay. Send us the link.
Run a link.
So just a couple of us still getting that note down. That's excellent.
Maths, man.
That isn't the
Just overloaded with knowledge so quickly, you just can't handle it. You get sleepy.
So much knowledge, and then goes in here, tries to process, and then like there's smoke clouds coming out, and then I
get overheating.
Okay. So guys, let's go back to these ones. So I told you these were walks. Are they anything else though? So let's have a look at this left-hand one. It's a walk. Are any edges repeated? So if no edges are repeated, what does that make it?
What's that?
a path.
A path. No.
No,
A trail.
Trail, yeah.
On the
Are any vertices repeated?
yes.
In that first one, sorry, just the first one. So if no vertices are repeated and no edges are repeated, what does that make it? A path. So this first one, and is that path open or closed? Open, because it doesn't finish where it started. I know, it's a lot of little bits of information to keep in your head at once. So it is a walk. It is also a trail, and it is also a path. It's all three of them. So it's kind of like saying Romeo and Juliet is a book, but it's also like a play, and it's also a romance. Like it can fit multiple different descriptions.
Told you what to do.
So that one there is a walk, a trail, and a path. Yeah. Okay, so guys, next one. Next one. Let's have a look here. I start at A, I go to C, then D, then E, then A. Are any edges repeated? No. So because it starts off as a walk, no edges are repeated. Can we say that it's also a trail? Correct? Are any vertices repeated? Yes. So normally that would mean it's not then a path. But because which vertex is repeated? It's just the starting one. So if it's a path with just the starting vertex repeated, what do we call it? A cycle.
Cycle of life.
Yeah.
Thanks.
Can you write that on the board?
So number one, I'll write it on the screen. Number one is
12 today, so.
Yeah.
Yeah.
Talking us.
I think so.
He's busy. Just
So this first one is an open walk.
I wasn't listening.
It is an open path. Sorry, an open trail. And an open path. This one here we would call a closed walk, a closed trail, and a closed... Oh, sorry. I got into the habit of writing closed. A closed... We don't really have a word... We have a special word for a closed path, and that is a cycle. So we'd call this one a cycle. So the thing I want you to take away, guys, always start with a walk and check. Does it have any repeated edges? If it does, it's just a walk. I'll show you on the next one. Because I told you down here, this one is A to C to D to E to A. In the next one we do, it does have a repeated edge. I'll give you a little bit more time to get that one down. By the way, what I've done there where I've highlighted the path, I strongly encourage you guys when we work through these ourselves to use a highlighter. It makes it so much easier to see what's going on. 100% recommend. If I believed in 110%, I would recommend it 110%.
You don't believe 110%?
No.
Statistically,
I mean,
110 is exponential growth. Whoa, big man works.
I know. Something chunky.
okay. Do we need another moment, guys?
Yeah.
Yep.
Let's copy signals.
Righto.
Oh, I don't have the second
So just a closed walk, closed trail, and a cycle. Okay, so now over here, guys, we have this abomination. So I've just color-coded a few different walks through this one. We're gonna start with orange. Oh, sorry, we're gonna start with green. I tell a lie. So green goes from A to B to C to D to H to G to B to E to A. So, what I might get you to do, can I just get you to draw that path, or that walk, sorry. So just ignore everything else apart from the green. So you start at A, go to B, And then to C,
Wait, so you just want us to do that?
just the green path. I don't care about the other colours, just green.
So you still want us to draw.
Yeah.
Do we need to draw the middle dot?
Sorry?
Middle dot.
Oh, that's just telling. Yeah, I know what you mean. I could have put commas there instead. I just did it. Okay, maybe I don't know. Do you mean like between the A and the B? That's got like that.
Everything, yeah, draw everything. Yeah.
Right. Okay. Okay, so guys, for this one, we go from A to B, B to C, C to D, D to H, H to G, G to B, and then B to E, and then E to A. So that's what that walk looks like. Just give you guys a moment. If you want to highlight it sort of like I did, you can just do all of it and just highlight over the top, say you're rewriting it. So I'll just give you another moment there. Would anyone like to borrow highlighters? I might have some up here. Are we ready to go, ladies and gents? Negative? Righto.
I just need to highlight.
Just highlight it real quick. Righto. Sorry? What do you mean by the middle? What do you mean by the middle vertices? Oh, there's no vertices there. It's just that the lines are crossed over.
Oh, you're drawing.
I'm drawing dots there. Oh, in that one there were, but in this one it's completely
Yo, let's go.
That's right.
It's baby.
Okay. So guys, let's classify this one. Would you say it is open or closed? Closed because it's a whole loop. Are edges repeated? No edges are used twice. So does that mean it? What does that make it if no edges are repeated? A trail. Now, if it's a trail that also has no vertices repeated, that makes it a path. Are vertices repeated? Yes. So therefore, this is a closed trail. So I don't use any edges twice, which makes it a trail, but I do use vertices twice, which means it's not a path. And because it's closed, because it ends where it started, we say it's closed. Okay? So it's a closed trail. For this next one, let's do the orange. So orange. Orange. Starts from A and goes to B. Then it goes to C. Then it goes to G. Then it goes to B. And then it goes to A. Okay, does it start where it finish where it starts?
Yes.
Yes. Does it use an edge twice?
Yes.
So what does that make it?
Is it a cycle? No. Infinite cycle?
A cycle is a special type of path. Does this satisfy the conditions for a path? No. Because what are a path has two conditions. What are the two conditions?
Is it one if it's
No
first or
edges
last?
are repeated and no vertices are.
Yeah, no edges repeated, no vertices repeated. But it fails both of those, so it can't be a path. A trail has one condition, no edges repeated. It fails that because that AB edge is you go along it twice. So that's no good. So that one, we just say it's a closed walk. Okay, what are we going to look at next? I think it's pink. Pink. So guys, this time for pink, we go from A to E to F to G to D. A to E to F to G to D.
Do you have a European? Thank you very much, sir.
So Shanti, do we have any repeated edges? Nope. So what does that make it?
We all are.
A trail. And then Vincent, does it have any repeated vertices? So what does that make it? A path. Is it open or closed? It's an open path. Open path. Last one, guys. We're gonna do what's left. Blue. So blue goes from B to F to C to H to G to B. So B to F to C to H to G to B. So that's my little walk there. Does someone have a go at saying what that one's going to be? Georgie, what do you reckon? Don't know yet? Give you a moment to gather your thoughts. Yeah. So it's a cycle. Are there any edges repeated? No. Are there any vertices repeated? Or just the start one? And if it's just the start one repeated, we say it's a cycle. And a cycle is just a special type of path. It just has that condition that that first vertex can be repeated for it to be a cycle. Are you feeling a little bit better about the differences, guys? A little bit? We've got some more practice ones to go through. Oops. Sorry, did anyone need that up for another moment?
Yeah,
No?
I do.
You do? Okay. All good.
Yep.
Okay, so once again, guys, to summarize, if it is just a journey between vertices, we call it a walk, open or closed. If no edges are repeated, it's a trail, open or closed. With no vertices repeated, it's a path. With only the first vertex repeated, it's a cycle. So we really have a walk, open and closed, a trail, open and closed, a path, and a cycle. So there's 6 different things we sort of need to be able to identify out of that. Okay, so do I have my... Let's get my highlighter out. Highlighter. Okay, so use the graph of 6 tourist locations in a city shown on the right to describe the following as either trails, paths, closed trails, cycles, open walks, or closed walks. So the first one, you start at the museum, and then you go to go away. You go to G, the gardens, and then you go to G, the gardens, and then you go to A, the art gallery, then you go to S, the shops, then you go to R, the railway station. So is it open or closed, what we just did? Open. I won't get you to write this one down, guys. We'll just talk through them together. So it's open because we don't finish where we start. Do we reuse any edges? G, because it's got a loop there, we used a separate edge to do that little maneuver. So yeah, we didn't reuse that. So what does that make it if we haven't reused an edge? Trail. Have we reused a vertex? Yeah, when we did that loop, we came back to G, so we reused that G vertex. So what would that make this thing here? An open trail, yeah. Alright, let's do the next one. We start at the shops and go to the railway station. Then we go to the clock tower. Then we go to the art gallery. Then we go to the gardens. Then we go to the temple. Then we go to the clock tower. And then we go to the railway station. So have we started where we began? No, so it's open. Have we reused an edge? So what does that make it? Yeah, walk. That's right, Casey. Because we've reused an edge. Basically, if you've reused an edge, it's just a walk. Anytime you reuse an edge, it's a walk. Okay, so let's look at this next one. C, the clock tower, to M, M, the museum. So apparently we're going via A, then to the shops, then to the railway station, then to the clock tower. Braden, what do you reckon that one's going to be? Cycle? Do we agree, guys? It's going to be a cycle. We haven't reused any edges, and the only vertice we reused was the first one to get back to it. So that would be a cycle. Last one now. So we're going from the gardens to the gardens. Straight away, because we've reused a vertex, it cannot be a path. It's going to either be a walk or a trail, depending on whether we reuse an edge or not. So we've gone to the gardens, then to the temple, then to the clock tower, then to the art gallery, then to the museum, then to the gardens. Yeah, so what have we done there, guys? A closed walk? Have we reused any edges? Closed trail. The reason it's not a cycle is because we reused that G vertex, not just as the first and last. If it was just the first and last one we visited, yeah, you're right, it'd be a cycle. Okay, we feeling all right with that, guys? The next one I think I will get you guys to have a crack at in your books. Ooh. So this is from the textbook. I don't need you to rewrite these. Can I just get you for these 6, just list what they would be? So I won't get you to write them out, but you should be able to just by looking at them tell what it's going to be. I'm going to give you a few minutes to do that.
Yeah.
You start at A, you go D, C, D, and then on to B. But because it's B,
If I
is the
roll up,
first one, because there's essentially two vertices that are being
probably not
reused.
that, probably burn.
So guys, like I said, just for each of those six, just say like open path, closed trail, cycle, whatever. I'll give you 2 or so minutes. Going straight to the source, Casey. So what do you reckon for A?
A, I think it's a
No edges repeated, no vertices repeated. Yep, open or closed. Oh wait, sorry. Because no vertices are repeated, you can upgrade it to a path.
it's not connected.
What I do, ladies and gentlemen, like, my first thought would be like, are any edges repeated? If an edge is repeated, what does it have to be? If an edge is repeated, has to be a walk. So I just look at all of those six and say, okay, and which one's an edge is repeated? And it looks like only one of them, only that one. So that's a walk. You've got to figure out then if it's open or closed. Does that look comprehension or horror? Alright, excellent.
Come on.
Sorry, I was trying to interpret E because those arrows are a bit odd. I'm like, oh, that makes sense. So what do we reckon, Jacob? So you're up to B? So are any edges repeated? Edges? No. So that means it's either going to be a trail or a path. And then you just got to look if any vertices are repeated. They are. Is it the first vertex that's repeated?
It's the last one.
It's the last one. So does that make it a trail or a path?
Oh. I think I probably wrote this down because I have cycle, but I probably have this written wrong.
A cycle has to start where it began.
Okay.
I can see why you'd say a path, but for this
Maybe
one,
a trail, right?
because it ends up at this vertex, so it's reused this vertex, but that's not the first vertex.
Okay.
So that would make it a trail, not a path.
That'd be a trail.
Well, is it open or closed?
It's closed.
Closed means it finishes where it started.
Ah, okay. So it's open.
Open trail, yeah. And what about C, boys? What do you reckon for C?
I have open path.
Yeah. Yeah, open path. No vertices repeated, no edges repeated. Might give you one more minute, guys. And then we'll go through some
I
answers.
think that's a cycle, right? D.
Yes.
Starts where it finishes?
I think
Is it though? Because to be a cycle, what is a
Oh, no,
cycle?
wait, it's not. It has the same edge.
Edge is used twice. So if an edge is used twice, what does it have to be?
A trail. No.
A walk. E, it's a bit annoying, but it starts there. Goes.
Ah.
That's what I was trying to figure out before. So the first thing it does is go E to T. Okay, guys, let's go through them. So, Nathan, what did you say for A? path, open path. Guys, do we agree open path for A? Yep, no edges are repeated, no vertices are repeated, and it doesn't finish where it starts. So, oh, sorry, I should get out of that. Whoops. What? Okay, my thing has started dying on me and it's not letting me write, so we'll just have to talk through it. So for that first one, yeah, an open path. The next one, who am I going to pick on? Haley. An open trail. Do we agree on an open trail? That one's a little bit tricky.
Yes.
It does finish on its original path, but not where it started. So if it finished where it started, we might talk about it being a cycle. But because it finishes somewhere else, it is an open trail. Okay. C, guys, what do we reckon? An open path? Did you not say that, girls, or?
Path is closed, then it's a cycle, so we need to have open in front of it.
If you just left it as pathway, that's fine. But I just want you to be thinking about open and closed. But you are quite right. A closed path is just a cycle. Yeah. Okay, D, guys. What do we reckon? A closed walk, correct. It finishes where it starts. Finishes where it starts, but it reuses an edge. That's D. Yeah, closed. Okay, E. What do we reckon, guys? Open trail. So no edges are repeated, but vertices are repeated. Yep, open trail. And then F. Open path. Yep, I agree. Okay, any questions from those ones, guys? No. Let's what's our time like?
Like 20 minutes.
Yeah, guys, can I get you to do this one in your books? I'll get you to actually draw the diagrams and then highlight it along the things and just say whether it's a same thing, open path, open walk, closed walk. There we go. If you want, you don't need to draw the lines bendy, the bendy lines. I'm not a huge fan of. You can just draw them straight. Makes it a little bit easier to see what's going on. I don't know, I think. Up to you. You can do it however you'd like. By the way, guys, I don't know if this helps, but this is the way I remember the difference between a walk, a path, and a trail. If you just go for a walk anywhere, does there need to be like anything built up for you to like follow? Like I can just walk in any direction I want, there's no real rules. But then like a trail could just be like, you know, the path made in, through the grass or something. Like it's very not built up still, but there's something there. And then a path actually has to have like really be in a place for a particular reason, so it's more like stringent, I guess. That's the way I remember it. A walk has 0 rules, a trail has a little bit of rules, and then like a path has the most rules. That's just how I keep it straight in my head. Like I said, it may not help you. What about B? B, E, B, C, D.
The first one's side.
I believe so, yeah.
Made it a little small. Well, not say that.
I'm just gonna use the same one. A to B to E to B to C to B to C to D.
A to B, okay, yeah.
Went back to B.
That should be.
So straight away, if you've reused an edge, what does it become?
Was it path? No, walk?
Some kind of walk, either open or closed. You've just got to see if it starts where it finishes. Finishes where it starts now.
Okay,
And that'll tell you if it's open or closed.
It's a closed.
Walk about.
Walk back.
I might give you another 2 minutes or so on that, guys.
Who's this teacher? Connection?
Wait a minute, is it open? Yeah, because it doesn't go back to the start.
You said it was closed.
It can't be closed because it's actually finished.
Confident?
You need to see.
Once it starts, I don't know. If you're a visual person, I think it starts really like easy. I'm a visual person, so this stuff like I don't find too bad. Well, things like other stuff I'm not as good at.
Wait.
Slowly. Pretty much.
Oops.
C. So F to E.
Okay, so it's already a walk.
And then F to B. And then
Went back.
F to E to D. Is it a walk? C?
It's
What edge do you reuse?
the E.
That is B a walk.
I think you. Yeah, it is.
Open walk.
Oh, never mind. Oh,
Because you reuse the E vertex, but do you reuse the any particular? So F to E to B.
because
Well,
F E,
you
yeah,
reuse
you go
F E.
back to here.
So I was going off Jacob's drawing,
Well,
and he didn't do two parts. Two edges.
What is C? Nothing done.
A B C D E B.
Is anyone else finished yet? Alright, I'll give you guys a bit more time.
Your battery's loosened.
20%.
Ugh, gotta plug it in.
So it's edges and vertices.
Use it same first.
So if any edges are repeated straight away, so basically we want these to not be repeated.
Means they don't go back to the start.
It's a trail.
So, like I said, guys, in the coming lessons, you're going to hear about, like, Eulerian trails and Eulerian paths and stuff. So the reason we're doing this is so that we're just feeling really confident about what's a path, what's a trail, what's a walk, what's a cycle. Okay, where are we up to, Brody? How we going, girls? Finished? What did I just see the time was? Guys, we've got about 15 minutes left. Just in the interests of moving forward, we might go really quickly through the answers. For A, what did we decide it was? Cycle? I'm writing in yellow now. For B, what did we decide it was? Open walk. For C, open walk again. For D, open trail. For E, closed walk. And for F, cycle. Oops. Cycle. Okay. Ladies and gents, if you haven't finished that off and you'd like to finish that off, it is in the textbook. I just screenshot the textbook for this bit. I have put up for the rest of the lesson, this is revision on networks. I'm going to give you guys a choice. You can do this revision on networks now for this last 15 minutes or so, or option 2 is you can continue working on the revision from yesterday. Individually, it's your choice. So if you're feeling pretty confident about networks, can I get you to take out the revision from yesterday? / homework from yesterday? Because, like I said, that I'm going to check everyone's on Monday. So we need to make sure that we have a solid effort done on both of those sheets. So that was one we did yesterday, actually. Like, not 100% of it, but I need you to have done a solid effort at it. Okay, so, can you put your hand up if you're doing the networks revision? Okay, I'll just get out of this and close down OBS for a second.